All right, welcome back to Coking.com's YouTube channel. I am here with our friends at Berthold in Germany. I'm here with Bernard Kraft, and he's going to be explaining to us all the things about the detector side of the gamma measurement system that they offer at Berthold. I would encourage you to go back and look at our videos where we discuss the source side and kind of all the interesting nuances about how the actual sources function. Today we're going to be talking about the detectors. So, Bernard, would you introduce yourself briefly?
Yes, hi, I'm Bernard. I'm a product manager at Berthold. I'm with Berthold now for 2 years. Happy to be with the company. It's a great company. And also happy to be here today with you to talk about scintillation detectors.
Perfect. It's scintillating. All right. So we have a bunch of things in front of us. Bernard, I think maybe we should talk about this. This is the external housing, and this is probably what I, as the user side, would be most familiar with seeing in the field. So what do we have in front of us?
Exactly. What we see here is basically the heart of most of the radiation detection systems we see nowadays in the field. This is called a scintillation detector. So if a scintillation detector is based on something called a scintillation material that's inside the detector, and if radiation hits the scintillation material, it's going to create flashes of light that we know as counts.
Mm-hmm.
And those flashes of lights we have to amplify, we have to calculate measurement values out of that, and that's going to be in the electronics of the device.
Yeah, that's a whole nother topic that we've talked about at length in other videos, so I'd encourage you to check those out. But the scintillators are here, right?
Exactly.
So you have two different types of materials. What are these?
So what we see here is the two types of scintillation materials we use at Berthold. One is a sodium iodide crystal. It's very heavy. You have it in your hand, right?
Mm-hmm.
And the other one is called polyvinyl toluene.
Polyvinyl toluene.
Oh, wait, you can pronounce it better than me.
This is the chemist part. This is the bit I understand.
Exactly. So for our so-called point detectors, for very small measuring ranges, we use the sodium iodide crystal because you have to grow them,
mm-hmm.
and you cannot grow them indefinitely. And for our long measuring ranges, for the rod detectors, we will use the plastic scintillation material.
And I think we were talking about for the coke drum application, other long level spans, you can go up to 8 meters in length with one single detector. So this bit will be 8 meters long.
Exactly.
Got it. Okay. So this is, I think you refer to this as the eye of the detector.
This is basically the eye of our scintillation detectors because this sees the radiation,
mm-hmm.
and whatever amount of radiation is hitting the scintillator, it will create more and more flashes of light, which have them to be measured and to be converted into electrical signals.
And these are just little tiny flashes of light, right?
Exactly.
And they're sort of aggregated along the whole length of this thing, and it moves to the next piece of kit here. So what is this?
So what we have here is a so-called vacuum photo-multiplier tube. So if the flashes of light hit something called the photocathode here at the beginning, they will knock out electrons. Those electrons get amplified throughout a series of diodes,
mm-hmm.
and they're getting amplified and multiplied, accelerated and multiplied. And in the end, you will have a measurable current that's created from a flash of light that you can barely see.
Perfect. So that's how we get the counts. And to do this amplification, it requires a lot of power. Is that correct?
It requires high voltage.
Voltage, let's be precise here.
Yeah.
Not necessarily power, that's different.
Yeah,
it's high voltage.
It's required high voltage between 500 and 1500 volts.
Okay. To do the amplification. And so one of the things that I think is special for us in the Coker audience that we only really get to see this bit. This photo-multiplier tube is contained within this housing, and it is a vacuum tube, and you said that these little pins can be easily damaged.
Not easily.
Well, not easily damaged.
It might happen.
It could happen.
Yeah, and if the vacuum would be lost inside, and you couldn't measure anymore.
So you have to be careful in how you install this, how you be gentle with this in the field, but you go to great lengths to make it as robust as possible. So those are some of our...
I wouldn't say that you have to be gentle in the field with it, because we make sure at the production site that you can actually go a little bit rougher on the detectors. We protect them against electromagnetic fields. We protect them against vibration.
Got it.
So what we do at the production site, we wrap the scintillators in aluminum foil, so they're protected against electromagnetic fields. So there's a metal shield around it.
Okay.
Right. And what we also do is we protect them against vibration by putting them in a special housing as well.
Okay.
So we go to great lengths to make sure those things don't break in the field.
Well, perfect. Well, one of the things that I always say, and you've heard it on this channel many times, is coker people are good at breaking things. So I'm just trying to remind us to, there's some electronics in here that we have to be nice to, coker people. I'm just warning you.
If you're having it in your hands like this, you have to be nice. It's fragile.
Perfect.
But so, if it's protected, you can use it in the field as you wish.
Okay. So this is the Photo-Multiplier Tube, the PMT, and this bit goes into here. Is that correct?
That's correct, yeah. This is connected to the, it's called a process interface and power supply, whatever you need to put on your circuit boards, whatever you need, whatever calculation power you need to have your measurement values, your sensor values. You want to have some compensations inside the detectors, compensation for example, for gas properties.
Okay.
You want to have some compensation for aging effects. The scintillator, also for the photomultiplier.
So these are basically the components that go in here that go into this housing, and we've broken this down, but this is all leading up to the reason why we're here today is you want to share with us a new development in your PMT technology. So this is kind of you called it the gold standard. This has been around with us for many, many decades now.
Yeah.
And you've developed a new version of this. So explain this to me.
So what we can see here is the so-called silicon photomultiplier. It's basically a semiconductor, and it's not as new as we would think. Berthold is using it for over a decade now. We're using it in the steel industry and also in the fracking industry.
Okay.
So what we see here is basically those little gray arrays on top here. They're replacing the photomultiplier vacuum tube. So those arrays are made out of tens of thousands of microcells, and every single microcell is acting as a photodiode. So it will create a flash, it will create an electrical current as soon as a flash of light hits it.
So all those little flashes of light that come through here meet up with the surface there, and
exactly.
It amplifies the signal.
I will not amplify it per se. This is why the array structure is necessary. So you will have the same electrical signal for every cell, but those are then summed up, and this is what makes the amplification.
Got it.
Right.
So one of the things that you were explaining to me about this new technology is that whereas this one requires relatively high voltage, not power, 500 to 1,000 volts, this, because it's a chip-based system, do not have so many different multiplication steps. It runs on a lot less power.
Yeah, it runs on
voltage.
Yeah, it runs on a bias voltage of around 80 volts.
Okay.
And this is why these systems these photomultipliers are prone to be used in detection systems that can run on the loop-powered.
Oh, that's interesting. So loop power. So unlike the original design where you had to run a 480 line up, way up the drum structure, this particular system, this new PMT design runs on a 2-wire system.
Exactly. It's not only in the coking or not only.
Well, that's all we care about in this.
Yeah, but it's in a lot of industries actually it's becoming more and more important because you have space limitations, you have energy limitations. So people start asking about loop-powered systems. So it makes this basically a system where the power and the transmitted signal is going over one pair of of the same pair of wires.
Well, it sounds a lot easier to install for one, but also to maintain it.
It's actually only for example, for hard connection, it will be only 2 connections, right?
Okay.
And it also makes things easier to plan. So also power lines are expensive. And also if you have a contractor who is planning your plant, they will be using much less time to plan your measurement systems in there.
So it's a reduction in cost, I imagine, in the actual hardware component, but then also all the other things that need to go along with getting this system installed.
Exactly.
Interesting. And the last but certainly not least, we discussed, all the great lengths you go to on the vacuum system to make it as robust as possible. This is much sturdier, as I recall.
You don't need to go to that great lengths to protect it. That's true. We're still potting it.
Yeah.
And we're still trying to protect our detectors as good as we can do.
You're still going to put it in a metal housing.
Yes.
For sure.
It will be, of course, in a metal housing, yes.
That goes without saying.
Yes.
Well, this is very interesting. Let me see. So this is the new and improved Photo-Multiplier Tube. And just to kind of recap for everybody's knowledge, you have the eye of the detector, the scintillator, sits full length, somewhere between 2 and 8 meters long.
Exactly.
That goes on here.
Exactly, yeah. You got it.
And you run your 2-wire system out to this detector, and now you have your continuous level instrumentation all in one neat little package. So
exactly, yeah.
Perfect. Thank you, Bernard. This has been very educational. We appreciate your time and sharing your knowledge and expertise with our audience. I hope you've enjoyed this video. You've gotten to see the insides of something that we all know and appreciate from the outside only. So thanks for watching, and check out our YouTube channel for all sorts of other interesting videos from vendors like Berthold and my travels around the world. Thank you.